Alright, hello and welcome. We're going to be covering some quadratic word problems. And this is from section 3.1, pages, I think it's 100, I want to say. Yeah. We're going to do the following numbers. Told y'all I told a few of y'all I would pick a few good ones and also cover ones that were on the test. So we're going to do 55, 56, 60, and 61. So let's start off with 55. And the prompt is write a quadratic function in standard form. I guess not standard form, there's no A there. Alright, so we have here our two roots. You have to write a quadratic function in this form for these two roots. Well, if those are the two roots, then I know that I can start off this quadratic in x-intercept form. If I plug in 8, 0 times 8 minus 3, negative 3. 0 times negative 3 is going to be 0. If I plug in 11 minus 0, 3 times is also going to be 0. So this is my x-intercept form, but let's get it into this form. Let's distribute. So that'll give us x squared minus 11x minus 8x plus 88. You combine that and put the f of x in the front. F of x equals x squared minus 19x plus 88. And that's it. Alright, moving right along. Let's go into 56 next. Write a quadratic equation in standard form. So ax squared plus bx plus c. Or you could do f of x instead of y. That has roots equidistant from 10 on the number line. Interesting. Okay, so they're saying, there's my y, there's my x. So if that's 10 right there, they want us to find roots that are equidistant. So we could find a root like, I don't know, 11 and 9, and then draw parabola through it. That would work. Or I guess we could go up to 20 and 0. That would also work. Something like that. They're both equidistant from 10. I guess we get to pick our own ones. Let's see. I'll pick these two roots, 0 and 20. You can pick any two numbers in those two. I don't know, because it looks fun. Also, I like to work with zeros. It seems like it might be easier than working with 9 and 11. But either way, let's set it up. So x minus 0, x minus 20. That's just x. So x times x minus 20. So that'll be x squared minus 20x. Or f of x is equal to, or y is equal to x squared minus 20x plus c. Well, there's no c, so let's just add that plus 0. So it's in the right form. Okay, that right there is our answer for 56. Making good progress, y'all. Moving right along. All right, let's jump into number 60. Modeling with mathematics. According to legend, I'm not going to write the whole prompt because they're a little giving you some extra information here. But according to legend, in 1589, the Italian scientist Galileo dropped rocks of different weight from the top of the Leaning Tower of Pisa to improve his conjecture that the rocks would hit the ground at the same time. The height in feet of a rock after t seconds can be modeled by this equation. Find and interpret the zeros of the function. Zeros to sketch the graph. Okay, well, let's find those of this function, and we'll use the zeros to interpret, or we'll sketch the graph and then we'll interpret it. All right, now we didn't know quadratic equation when we were doing this, so let's just see if there is an easier way than quadratic equation. Just right off the bat, I'm wondering, is 196 a perfect square? If it is, I know that 16 is a perfect square. It's 4 squared. And t squared is a perfect squared. So let's just see. Is 196 a perfect square? Oops, now I got it. 196. Hey, it is. It's 14. All right, I'm going to use my old method instead of quadratic formula. We'd be done with this pretty quick if I use quadratic formula. That's our a, negative 16. Our b is 0 apparently, and then our c is 196. But let's do it in a different way. Let's do 14 squared minus 4t squared. For those of you guys who don't know why I'm doing that, follow along. I'm using this formula of perfect squares where I have something squared minus something else squared. I know it's confusing that I use a and b. Maybe I'll do it differently next year. I think some people got confused and they thought that this was coefficients of a quadratic, but if I got a squared, 14 squared, minus b squared, 4t squared, I can rewrite this as a plus b times a minus b. So going along with that, I can rewrite this as my a, and that's my b. I can rewrite this as 14 plus 4t and 14 minus 4t. And they want us to find the zeros of this function, so we would just set this equal to 0. So if we set this equal to 0, we just have those individual parts equal to 0. 14 plus 4t equals 0, and 14 minus 4t equals 0. So let's do this one first. I'm going to go through it quick. I subtract 14 from both sides, divide both sides by 4. I'll get t equals minus 14 divided by 4. And subtract 14 from both sides, divide by negative 4. T is going to equal negative 14 over negative 4, or just 14 over 4. So my two answers for t here are going to be negative 14 fourths, or negative 7 halves, and also positive 7 halves. So if I were to draw this out, I would go up to 196, and then I would have to draw negative, that's like 3.5. negative 7 halves. That's divided in 2. It's 3.5 negative, 3.5 positive. Let's go 1, 2, 3.5. 1, 2, 3.5. I know this is out of whack, but this is 196 up there. This is 3.5, negative 3.5. Now let me just draw my parabola. Now that's the parabola. This is the path that you dropping, or Galileo Galilei dropping his rocks from the top of the Tower of Pisa. This is the path that they followed there. He didn't drop them in both directions. We just used this part of the parabola until it landed after 3.5 seconds. All right. I'm recording. I can check that out in further depth if you have additional questions. And to round us out, let's do problem 61. This is very similar to the one that we just had on a test. You make a rectangular quilt that is 5 by 4 feet. 5 by 4. Okay. You use the remaining 10 square feet of fabric. So you got 10 square feet of fabric left after all this. So this cost you what? How many square feet is this? 20. That's the area of this, right? So this area is 20. That's the area of this quilt so far. You have 10 square feet extra, and you're going to use that to add a border of uniform width. Now, we had a similar problem like this where we had a pool where we added a deck of uniform width. The concept is the same. We're going to add some border. Pretend that that's uniform width. We're going to add some border, and we're going to cover it, or we're going to make sure that each side length, I'm going to use X for my variable. It's just the most straightforward. It's what I'm used to. That length is going to be the same length as that length. It's going to be the same length as that length. It's going to be the same length as that length. In every direction, this is all going to be the same. So I take, oh, the video stopped.